Welcome everybody. I'm Paul Callaghan, Director at OLEOLOGY. I've been involved in water treatment for the last 20 years and prior to that time about 15 years in the oil industry with an engineering background. So we'll cover this morning, the emphasis is the removal of PFAS with the MySelex technology. MySelex is a fixed chemistry. It's an important part of what we do. It's a fixed chemistry. It's an oil absorbent, so it's oleophilic and hydrophobic. The chemistry is fixed into filtration media, often cartridge filters, and there's a range of cartridge filters to give an idea. The cartridges themselves have ranging pore size, which increases the ability for interference and capture by chemical bonding of the targeted contaminants onto the filtration media themselves. Being hydrophobic, the filters end up as a dry waste, which is an important part of what we're doing as we get further into the discussions. It's non-leaching and non-toxic, which is a permanent infused chemistry, which is important. So whatever we put into our system in order to remove contaminants, we take out. The only thing that ends up passing through our filters is water, and on the discharge side, it is water or low levels of contaminant as allowed by the various regulatory bodies. So in that sequence, we capture and separate oil, we polish, dispersed, emulsified, soluble organics, oils and PFAS to below detectable levels. And this is in a sequence. And then we polish soluble contaminants, and namely PFAS, which we've been working with since about 2004 with the first real foray into a system for air services in 2006, albeit under a different guideline. 2010 and 2016 were also significant landmarks for us. 2010 was when we went into doing a number of trials and on-field work for air services at different locations around Australia. 2016 was the time at which, during Senate Estimates Committee, we were nominated as the commercially viable operation, along with Rembind, for a binding of, they were for binding PFAS into soil, ourselves for polishing water contaminants. So really the objective of our discussion here, and to share with yourselves as the regulators and development of environmental protection policies, is the knowledge that there is a bridge between the differences in industry and, I guess, the environmental objectives. Industry wishes to make commercial profits, which is understandable. The environmental protection agencies and ourselves working in that same space seek to improve the outcomes for the environment as a method of treatment of water in our case, but importantly to bridge the differences between just cost and environmental objective. It's important to be able to reduce the cost and show to industry that there is a way of environmental compliance to a high degree, not to a lesser degree, but to a high degree, in order to improve water treatment as it pertains to ourselves, such that we're able to reduce the cost of implementation and operation of such systems and achieve the environmental outcomes. We use MySelex technology, and we've developed the MySelex technology in Australia further for PFAS development. All that work's been done here, but principally MySelex removes hydrocarbons, BTEX, organometals, PFAS and mercury, to name a few of the contaminants of removal. And it does it in a very small footprint with a minimal operating cost, delivering a very small amount of dry waste compared to the volume that's treated and compared to comparative conventional technologies.
Oh, somehow we lost you. I cannot hear you.
Just 1 minute, please. Somehow or other you've managed to get onto a webinar. I might get you to call back. Sorry about that, everybody. So MySelects does this in a sequential stage filtration approach. The range of filters that I showed earlier is a small part of the system, but it's a sequential reduction of contaminants through the process in order to achieve a robust outcome. So in order to discuss the PFAS reduction, it's critical to have a preliminary sequence of removal to remove other contaminants which will otherwise reduce the compliance ability of the polishing system. So it's important to remember that we rarely, if ever, find PFAS on its own. In industrial waste, it's part of a larger wastewater treatment system. We've done quite a bit of work for some of the major wastewater treatment companies around Australia. Their issues generally are one of emulsified hydrocarbons preventing conventional systems such as GAC and ion exchange from functioning correctly. So in our system, we are able to address that by having reductions of those contaminants which otherwise render the PFAS polishing system inoperable. So we liken that to the analogy of peeling an onion. The ability to remove on the outer surfaces the free oil, which is generally fairly easy to do, but it gets harder as you progressively work your way towards the targeted contaminants, the highly soluble elements of PFAS and phenols and those types of contaminants. But in order to get to them, you need to remove the oily emulsions, the semi-soluble organics, the dissolved contaminants that sit beyond that, and to do that in a manner which prevents any fouling of the polishing media. Now, the MySelect system does do that, and by those stages, we're able to remove the hydrocarbons, the soluble hydrocarbons, the BTEXs, the dissolved metals, and we do that in order to reduce the load on the polisher. If you had a granular activated carbon or an ion exchange, and you didn't have the pre-filtration and the robust nature of that, you would ultimately end up with an early failure and breakthrough. The other issues that we find that we don't have with MySelects, because MySelects has permanent immobilization, it's permanent capture. We don't suffer from the issues that revolve around steric hindrance, which the capture and release mechanism that's associated with carbon. So those elements significantly make us, in our approach and our chemistry, different from that of conventional players. And that's what leads to the smaller footprint. To give a brief history of the work that we've done, principally with air services, we first began work out at the Perth airport in 2004, where we were treating water from the fire training ground, which had highly emulsified hydrocarbons in it, conventional discharge treatment via oily water separators, hydrocyclones, etc. Couldn't remove the emulsified hydrocarbons. We were able to do that and provide discharge down to 0.6 parts per million in those days with a small sequence of filters. What we didn't know at that time was the impact that we were having on removal of the emulsified hydrocarbons was in fact the same sequence that we ultimately discovered when we were actually doing work to remove hydrocarbons and PFAS from groundwater in 2011 around the Perth airport. In order to remove the PFAS, we had to remove the emulsified hydrocarbons first. And we found that we were doing that in retrospect by review of the work that we did in 2004 to 2006. From there, we moved on to the Launceston Airport and continued to do work around the fire training ground for treatment there. Becca then did independent work for Air Services at the Tullamarine Airport in 2016, where we supplied equipment for them. They ran their own independent trials and reported directly to Air Services on the success of that. From there, we had industrial plants built in 2018 and an installation put in for defence in 2019. Suffice to say, we've now taken the work that we've done back to the US, and we've done similar discussions as we're having here this morning with the US EPA, and we're about to launch into our first installations over in the US with pilot plants commencing in the next month or two. Importantly, around the Miselex method for treatment, we are able to remove the full range of compounds, both precursors and those analytes that we are able to assess at the present stage with a limited amount of analysis that's available. And I think that's important because of the 3,500 contaminants that we knew of in December of 2018, it's now estimated that there's about 6,600 contaminants in the PFAS range. Some of the technologies really concentrate on just a few of the analytes, the PFOS, the PFHXS, the PFOA. We don't limit ourselves to that. The Miselex affinity for organics applies to synthetic organics, of which PFAS is certainly part of that. We're able to remove the full range of those analytes to below detectable levels with the system that I'll show you a snapshot of shortly. So in terms of future-proofing ourselves as we begin to understand more of the implications of these contaminants, which are only man-made and have got a half-life of up to 90 years, we're able to remove those contaminants across the board and end up with a dry waste. It was interesting, I was looking at the contaminant levels that are estimated to be in the world's oceans, somewhere between 10 and 80 picograms, which if calculated out, and it's an interesting estimate, but if you calculate that out by the volume of the world's oceans, it ends up at around 120 million litres of PFAS that's contained within the world's oceans at the moment, which is a very significant amount considering that the world's biggest oil spill is estimated at about 200 million gallons, and that's from the Deepwater Horizon. The part with the Deepwater Horizon, I guess, and hydrocarbon spills is that they're able to be addressed. You can see them. The hardest part with PFAS is you can't see it. It's bioaccumulative and having a much longer period of time in existence compared to hydrocarbon spills. I think it's far more damaging for the biota and ultimately humans at the end of the food chain. A small comparative chart to give you some idea of what we can do. Much smaller footprint, much higher volume of flow in that relatively small footprint. We remove hydrocarbons. Moving across the chart, we remove PFAS below detectable levels. Relative levels of removal are shown for comparative, conventional, I would call them, systems. We have very limited waste. We don't regenerate the waste. The waste is able to be taken and thermally oxidized, which certainly is a better way to deal with this permanently, and we know that's a preferred method for defence to remove the contaminant once and for all from their sites. We don't suffer from a blinding also because of the way that the filters are staged sequentially. So whether it's suspended solids, sludge, emulsified hydrocarbons, or other levels of hydrocarbons, MySelects will continue to operate through the system. Just on the waste, MySelects, if thermally oxidized through a plant such as Renix as exists over in South Dandenong in Victoria, we end up with about 5% by mass of waste of inert compound, of inert elements rather than compounds. So a significant reduction of the waste component. And through the whole of the costing of this, which is important to industry, it's a low cost to set up, it's a low cost to operate, and it's a very low cost in terms of waste. It's a dry waste, it's safer to transport, safer to store, safer to treat, and no residual at the end of that treatment process. So what does all that look like? Well, that would be two 20-foot containers. The container at the forefront is the stage filtration sequence. This particular setup will treat about 750,000 litres of water per day. The MySelects cartridge filters are in the foreground. The water having passed through those then passes through the polishing element, which is in the background, which is the MySelects performer media. That performer media is also part of the dry waste disposal and treatment, which leads to future or zero liability for the generations to come. One centrifugal pump is all it takes to run this system. It's very low energy. The ability to scale up is such that in two 40-foot containers, we're able to treat about 4 to 5 times the volume of flow that's shown in this particular instance here. How the two containers coordinate to provide the level of treatment is shown in this next slide. It's a logarithmic slide, and it starts with the treatment via the cartridges that you see on the left-hand side below the graph. The cartridge treatment removes about 90% in this instance of the contaminants from the water, which means very low levels of contaminants are removed through the bulk polishing, which enables the bulk polishing media to operate for extended periods of time without need for change. Again, leading to low cost, but important, leading to high levels of compliance for discharge at below recordable levels. This chart dates back a few years. Subsequent to this, we have lots of data on discharge levels below that of the super ultra trace recordable levels now. We did some comparative work to see how, with the same empty bed contact times, the performance of MySelects is compared to that of granular activated carbon. So the upper graph, again shown with the same pre-treatment. So we pre-treated with the MySelects cartridge filters in this instance, and then through the GAC. And we had higher levels of discharge, meaning we either need more stages of GAC, which leads to greater footprint, more waste, or we need to do something else, which is akin to what we have with the MySelects. Many of the GAC systems also use ion exchange afterwards, but again, that leads to more footprint, higher levels of energy consumption because there's greater pressure drop across GAC than there is across the entire of the MySelects system. that pressure drop increases with the addition of more polishing stages, such as more GAC stages or ion exchange, leading to greater cost. GAC and ion exchange can be regenerated, but that leads then to subsidiary waste, which generally is either methanol in the instance of ion exchange, which is dangerous and hard to handle, and then further for treatment as additional cost and transportation of hazardous waste in a liquid form, or in the instance of GAC, greater volumes of sludge. We don't provide the Miselex pre-filtering to other vendors. We provide the entire system as a whole because we know of the performance that we're able to achieve. To provide an idea of what that means in terms of size of footprint, there's a conventional system at Lake Cochrane and Williamtown, an image courtesy of Google Maps. You can see there's quite a considerable amount of plant that's in evidence on this site. And the focus on this is the removal of PFOS, PFOA, PFHXS, and 6,2-FTS. In discussions at the site, there was some level of concern when it was suggested that Miselex could remove all the elements below the levels of detection in an open forum. Many of the other participants said that is not possible. It is possible. The technology is here to do it now, and we would do that in something of the footprint which is equivalent to the 4 20-foot containers shown in the red overlay on top of the system that's existing at site. So just to reiterate, Miselex will remove the hydrocarbons and the PFAS in the one system in the containerized plant that I showed a little bit earlier. We'll remove those PFAS contaminants to non-detectable levels, and that's by top analysis as well. And it's a very small footprint. Consequently, very small cost to set up and very small volumes of waste. Look, that's what I wanted to alert you to. It's been relatively quick, but happy to take any questions from any of the participants now. So over to yourselves. So if you want to unmute, we can have discussion.
There we go. Yeah, thanks for that, Paul. I have one question. It's have you used the technology, and because we did Shamali's on the line, could maybe talk a bit more about it. We did a review of the technologies that were actually were published recently, and one of the things we sort of looked at was how these sometimes they put into like a train. So you might have some, say if you're dealing with soil, you might wash the soil and then treat the water somehow. Is that something you've looked at?
Yes, yes, it is. Yeah, so we've done work here in Western Australia on soil treatment. Principally, where we have been able to. Others have done the soil washing. We've recycled the water via a Miselex system to remove the PFAS and then enable that water to be reused for continued soil washing. So if that's the question, then yes, yeah, that is definitely. And we're aware of. I think the Westgate Tunnel is one of the major areas of concern over with some of the contractors at the present stage in Victoria for doing something akin to that. So we are in discussion with some people on that particular application.
So I got a question. Now you showed comparison graphs between GAG and your technology.
Yeah.
Normally GAG followed by ion exchange. You haven't put that in your graph. Is there any comparison being done after ion exchange? How the quality changes? So how that compare with your technology?
Yeah, we didn't do the work in comparison with ion exchange. Simply, it wasn't available when we did that. That was 2018. We did that particular work as comparison. What we are aware of is the size and the quantity of regeneration that's required for ion exchange. And we have, in part, provided solutions for others where they have used GAC principally for polishing, but in order to achieve the levels of discharge that were required for, and this is principally for contract waste services, in order to achieve the discharge of sewer that was required, they were seeking to enhance their treatment system. So we've actually done work for waste contractors in that area, and they were assessing Miselex compared with GAC and ion exchange as a sequence. So the GAC and ion exchange or the Miselex sequence, and the footprint was certainly much smaller. The operational cost was significantly lower, as was the waste component. And it's a combination of all those things, as you can understand, that actually make the total operating cost comparison the one true element where you end up comparing apples with apples. Does that answer the question? Or? Were there?
Off there, Paul.
Hello, I'm Carlos here. Paul, can you hear me?
Yes, I can, Carlos.
All right. Yeah, I just put here in the chat one question that is like from the explanation that you have provided. It seems that these cartridges, they work in a similar principle to coalescent filters, or like could you explain a little bit more about the concept or the working principle of this material?
Most certainly, most certainly. So Miselex, the actual compound Miselex is a gel. That gel is taken and it has two very key properties. It's hydrophobic, and that leads to an indefinite shelf life. In other words, you can pass water through it continuously and the product remains inert in the cartridge filter, like a sentinel waiting for the contaminant that it has affinity for, which is principally organics, to be in the water. Now, dependent upon the pore size of the cartridge, depends on the amount of contact that's achieved by the Miselex. So Miselex and the principle of those cartridges, I showed a series of 3 cartridges, I think in the second or third slide. The principle of that is to remove sequentially and by stages larger oil droplets down to very small oil droplets, down to dissolved contaminants. So at that stage then we're looking for molecular contact between the Miselex and the contaminant that is targeted. So in the instance where we have, say, take a fire training ground which has used a fire training foam, and at the end of the exercise, where, say, kerosene or aviation turbine fuel has been used, there's a residual volume of that which is then, after the training exercise is done, ultimately ends up going into the sump in the training ground, and it mixes with the fire retardant or the firefighting foam. That forms an emulsion. That now the emulsions have a couple of key properties. One is that the oil is very finely dispersed, if you want, in terms of oil droplets through the water body. That makes it not want to coalesce. So in order to overcome that, the way that Miselex removes that emulsified hydrocarbon from the water is Miselex, with its affinity for the organic, the oil droplet itself, the carbon chain, the hydrogen carbon chain, when it comes into contact, when it, being the Miselex, which is infused onto the filter, comes into contact with that dispersed molecule of hydrocarbon, it will bond between the molecule of oil and the Miselex. Thereby, we're able to remove that particular emulsion. And that will be, and that part of the process will be in the middle stages of that sequence of staged cartridge filters. So at the front end, we'll remove the free oil, if there's any residual free oil and small droplets. We'll then remove some of the dispersed oil, the emulsified oil, and passing through all of these initial cartridges will be most of the soluble components, highly dissolved in PFAS. And as we get further down the cartridge chain, we then begin to remove those elements in their higher levels before we get to the polishing stages. So we're not necessarily coalescing, as I guess principally referred to as a coalescent filter, but it is capture, and there is a degree to which coalescing does occur, which aids the second stage of, or the stage of filters following, to further capture those coalesced droplets, as does occur as you move through each sequence of filters. The principle behind it, though, is to enable polishing to occur to a high degree with very low levels of usage of that polishing system, is to remove everything else beforehand that can be taken out. And we are able to remove stable emulsions in the oil industry. I've been working with the oil industry for a long period of time, in the mining industry. We're able to remove stable emulsions, chemically stable emulsions, and to which I would refer to some of the condensates that come from the coal seam gas operations, and also in the Northwest Shelf area, which will remain stable. We can sit them in jars and watch them for 6 to 12 months, and they will remain milky white. They will not separate out. So we've been able to provide a system whereby we can remove those by filtration using the Miselex filters. So we've got that level of robustness within the system, which then improves our ability and confidence to deliver water to the polisher, which has only got low levels of PFAS or other low levels of organics, for the polisher to remove, in order for us to be able to confidently say that we can remove to lower than detectable levels for PFAS contaminants across the full range of analytes as it now, and that also applies for other things such as BTEX, etc.
So Paul, the other question is like coming back to the original, one of the first slides that you were mentioning, this onion model.
Yes.
As well as you are peeling the onion, so you are cleaning the fluid that is contaminated. You end up with the onion itself. What I mean is, as you go through the cleaning process, on each stage you will be producing some waste streams. But in the latest diagram, you were showing that the only waste is the micelles the micelle material itself. So can you explain a little bit that one? Because if I'm removing hydrocarbons from the stream, so I imagine that I will get a stream that is rich on oils. But then when I go through the further stages of micelle and the polisher, then I should be getting another stream that is richer in PFAS and the smaller components.
Yes. So in essence, you're correct. The difference between the MySelex and the closed system of removal of hydrocarbons, if we're using hydrocarbons as the example, the hydrocarbons are bound to the cartridge filters in those cartridge housings. So there isn't a waste fluid stream as such. So we end up with a dry waste. So the cartridges ultimately require changing. So they will get to a degree of saturation in which then you get a slight pressure rise, which is an indication, and we can also monitor remotely the contaminants, and the turbidity, the oil content in the water stream at various places through the process and through the various stages of filtering, so that we know when to change those cartridges out.
So once you have so once you have breakthrough, so then I guess that the facility operator like realizes that that it's time to change the cartridges.
Correct.
And you end up with a dry material. But you mentioned that the cartridges, they are made of a gel. So this gel is going to be saturated with PFAS, and
Yes.
then that needs to go to to an incineration facility or something like that.
Correct.
But then the question is how, like what sort of materials you end up with when you incinerate? Like is this gel purely organic based that will be easily to incinerate, or it has some metal components that they will end up in the ash?
It's the MySelex, the patented MySelex product is a naturally occurring synthesized product which has high affinity for organic materials and synthetic organic materials. So it in itself is non-toxic and non-leaching. So when we incinerate the waste material, the dry waste material, we end up with less than 5% biomass of the original mass. The products that are produced as a result of that incineration are elemental in nature, and we don't have any residual PFAS contaminants in the waste material itself. So in essence, to take the scenario that you're painting, Carlos, if we're operating a system, in fact, we'll use the system that we installed for defence in 2019. That was estimated to operate for a year, treating a number of millions of litres of water. In fact, it's treating about 2.5 times what they estimated they would be putting through there in water coming off their fire training pad. The estimate for the total waste on that facility was the equivalent over 1 year of operation, of about half a pallet of material that's uncompacted. So that's the filters and the waste out of that operation for a 12-month period of about half a pallet. The absolute weight of that would be in the order of about 120 kilos of cartridges. The MySelex cartridges, carbon and to use this as an example, carbon for hydrocarbon capture, depending upon the hydrocarbon chain that you're looking at, is somewhere between 3 to 20% of its weight. MySelex, by comparison, has the ability to capture 200 to 300% of its weight. So its ability in terms of service life is considerably longer than a large volume of carbon. And thereby the commercial and service life advantage is attained. So that's what leads to the smaller footprint. And that's also how the lower pressure drop is achieved, because MySelex has very low pressure requirement to run through a system. So we only use very small pumps. Water will essentially flow through MySelex, which is why it's used in stormwater applications also, because gravity will flow through, gravity on its own is enough to flow water through the MySelex. Filter stormwater for discharge in certain applications. I'm not saying for PFAS, that's a different application, but my point is to illustrate how little pressure drop is required. Does that help, Carlos?
Yeah, that was good, thank you.
Are there any other questions that people have that we could perhaps discuss a little bit more in detail?
Hi, Paula. I'm Shamal here. So with the cartilage, how do you identify it has reached this capacity? How often do you change it?
Shamal, that's a good question. The cartridge capacities are one that's known. So we're able to identify either by volume of flow, which is one method. So we accumulate the volume of flow of water. We can also look at the pressure drop of water. So to take the volume of water that's flowing through there at a known rate of contaminant, we're able to, by forward estimates, predict at a relative percentage of surety when the cartridges would need to be changed. Alternately, we can wait for a pressure rise on those particular cartridges, in which case we're then able to, and it's a curve of pressure rise, we're then able to predict when they need to be changed. So we have two methods, one's by volume, the other one is by pressure. Alternately, we provide a system whereby we're able to monitor by inference of saturation. So we can monitor turbidity, conductivity, oil content, for want of a range of predictable nature of when the cartridges should be changed out. And on top of that, we do regular water sampling in order to analyze and then aid the client in their pursuit of optimizing the system operation, servicing requirements, and forward scheduling of servicing and maintenance. Is that?
Yeah. So do you think like the dissolved particles like turbidity have an effect on the efficiency, like blocking the cartilage and that sort of issues?
Yeah, they do. They do. I mean, a filter is primarily what it starts out to be. So in the MySelex cartridges, they are, for want of a better description, they're a standard cartridge that is then infused. So the basis of the filter is its ability to filter down to 20 micron, 5 micron, 1 micron, 0.5 micron, 0.2 micron, and lower. In order to do so, there will be removal of other contaminants in the water, including bacteria, biological activities, cyanoalgal blooms, all range of other contaminants in the water. So turbidity certainly does have an impact on the filtration capacity of the filters, which is why in that progressive train, and if you counted the number of cartridge housings in the first the two in the first of the two containers, you would have seen that there's actually 12 cartridge housings in there. And within those, we use plain cartridge filters to protect the Miselex cartridges further upstream. So we remove base contaminants such as solids, finer suspended solids, turbid nature of elements from the water prior to coming into contact with the Miselex cartridges, which are really there for the removal of the organics, the hydrocarbons and the PFAS, all leading up toward the polishing stage. So what we want to deliver to that polishing stage, and this is the part that Becca really liked when they did their work for air services, is that we homogenize the water. So the water on the inlet can range between spikes, very high and very low levels. It doesn't matter to us. Via that initial stages of cartridge filtering, we reduce those contaminant levels to a very low level of almost homogeneous nature. So by the time it reaches the polisher, we are certain of removal to compliant levels. We don't need to, and the important part about that is, and what really does make a difference, is that in some systems, if you're seeking to add a chemical, you're trying to, or the service operator is trying to predict the amount of chemical that's going to be required to meet a spike. If you have too much chemical or too little chemical, it's out of balance and it causes upsets in the conditions of the water. It may raise or lower the pH too much. The addition of extra chemical is a cost if unneeded. But in order to treat for spikes, which is where all the problems occur, then this fixed chemistry overcomes that. We don't have issues with turn down in operation. So we're able to maintain the quality on the discharge side by ensuring the inlet to the final polishing stage is always a constant. And that's something that's been proved in the either the upstream in offshore applications or in refinery applications, where Miselex is used as a way of overcoming issues that really are upsets as a result of chemical imbalances within water treatment systems further upstream. We use the same principles of operation, and when we're looking to talk with contract wastewater treatment companies, we look upstream of in their operations to see if we can assist in that chemistry in order to reduce the likelihood of spikes and improve the quality of water through their existing plant before we get to the treatment of PFAS, for instance, at the polishing stage. We don't just want to put a polisher in and say that will work. It will work, but the life and service of it will be shortened because we haven't dealt with the preliminary stages, which are critical to getting good service life and lower costs and better economies out of the operation.
Yeah, makes sense. Thanks.
With pleasure.
Well, this is Saeed Hastan. Thanks very much for your presentation. Sorry, I joined you later, not from the beginning. So I'm just curious about that. Did you come across any PFAS analytes which are really not reducing lower than the detectable levels using this Miselex?
Oh yes, yeah. We have clients who don't wish to reduce their levels to less than recordable levels, in which case we provide them equipment to that requirement. So, and that can be running at empty bed contact times of higher than what we would normally run. It could be just the utilization of cartridges only and not polishing. We don't really understand why people would want to do that, but that certainly is, I guess, is at their behest. So if yes, if you run it at higher levels than what's required, you will get less takeout. It's about contact between the offending contaminant in the water and the Mycelex compound itself on whatever the media type is through the stage of sequencing. So if we do that correctly, we get lower levels than lower levels in detection. If you run it at higher than the recommended flow rate, then you get less contact and thereby have carry through.
Okay, thank you.
Well, was this technology, is it developed, is it an Australian technology, or is it something that's been adapted from overseas?
So it's been adapted from overseas. So we've worked very closely with Mycelex in the US for approximately 20 years. Mycelex in the US have not done anything other than oil removal from water, or hydrocarbon removal. So principally they're involved in upstream and downstream in the oil industry, and you can see that on their website. We've done all the development work and all the IP work on the application and the installation, the sequencing, the operational flows with the Mycelex technology. So we've now done that here, and we've an agreement with Mycelex to take their technology back to the US and apply it to PFAS in the USA. So we're quite proud of the fact of what we've done here in Australia. It is. It's really quite unique. So, and just to that point, we had we presented to the board of Mycelex earlier this year on what we've done, and subsequent to that, we reached agreement to be able to take it back to the US. We had a long session with the US EPA via video conference late at night about 2 months ago. They are extremely interested because in their applications, they draw a lot of water from their river systems, which, and if you've seen the movie Dark Waters with Mark Ruffalo, you'll understand what I'm talking about. That's also the area where many of their industries discharge into, which, you know, is analogous to where all our sewer waste ends up. So wherever we can, we're working with environmental engineering companies or consultants and wastewater treatment companies and I guess the water corporations, the sewer operators, to ensure that they understand that there is a way where we can treat, you know, most of the industrial waste which comes through wastewater treatment companies before it gets into the sewer. So, and it's, you know, it's viable operation to do so.
Yeah. Excellent.
We're about to run out of time, I think. So if there's any further questions, then please send our emails in, or we're happy to reconvene and have another session at some stage in the near future if Barry, if that would be beneficial to all and allow people to digest the information. We can certainly send out further information as you may require.
Well, thanks very much, Paul and Sash, for organising. It's, I mean, what's really helpful for us is to have these sort of discussions around these technologies. So I mean, the main thing for us is really to educate ourselves about what's available, what's out there, what works and what doesn't, so we can sort of assess, you know, when we get requests coming in to assess approvals or things like that. So really appreciate you taking the time to do it. Yeah, and if we have any further questions and things, yeah, I think we've got Sash's contact details and yours now. So
yes,
really
well,
yeah.
feel free.
Yeah, thank you.
Feel free to use them. All right. Thank you very much, Barry. Thank you, everybody, for listening in. We hope we can assist cleaning up the environment. That's it's part of the legacy of what we work for.
Right. Bye, everyone.
Okay. Thank you all. Bye.